Alright, before the movie starts, we'd like to get on a serious note. Lab safety. It's a real important topic to us. Even though we're enemies, this is all something we can agree on.
Yep.
Alright, first we want to make sure you always dress appropriately, with an apron and some good old goggles.
And sometimes when you're working with dangerous chemicals, you might put on long sleeves and gloves. And make sure you always have the proper footwear on.
So you're not looking like this kid out here. No sleeves. This kid, he doesn't have any shoes on. He's wearing bare feet in a Shaq jersey.
What is
really?
he doing? What is he doing?
Shaq's hard. Kinda. Alright, another tip is to never eat food or drink in the lab.
No, you're not allowed to taste chemicals or sniff the chemicals unless instructed upon by your instructor.
And if you do happen to have long hair in the lab, always make sure you put it back in a ponytail. You wouldn't want it getting into any chemicals or anything, so always make sure you're safe with that.
Make sure you always know where your emergency equipment is.
Such as the eye wash, the shower, and the fire blanket. Don't ever use these unless it's an emergency, or you could be expelled from school.
Make sure when you are using pipette, do not pipette by mouth or nose.
And when you do use a pipette correctly, use a bulb and make sure you know how to construct it. Always hold it up here by the end and slowly insert it in, instead of going like this, where you could easily cut yourself.
Before you use any lab equipment, make sure you wash your hands. And you also want to make sure you wash your hands after you use lab equipment, just in case you get any acid on your hands.
Now remember, last but not least, always remember to listen to your instructor, especially if you have a great one like Dr. Lyman.
You can have as much fun in chemistry lab as you want, but remember, safety first.
Our titration was a strong acid, strong base. This is an example of a strong acid with a weak base. Take, for example, 100 milliliters of 1 molar acetic acid with 2 molar NaOH and 10 milliliters of NaOH. Here you convert both to moles and you get 0.10 moles of acetic acid and 0.02 moles of NaOH with the spectator ions gone. You subtract for the smaller amount of moles to get 0.08 moles of HAC and 0.02 moles of acetate. You divide by the total liters, which is 0.110, to find the molarity of both. In this case, you get 0.727 molarity of HAC. You then break apart the HAC into 0.27, 0 molar of H plus, and 0.182 molar of AC. You subtract x, and add x to the 0.182, and then you solve here using algebra. We have a solution. To find the molarity, we do a titration.
Titration is a technique where a solution of known concentration, in our reaction it is 0.10 molar NaOH, is used to determine the concentration of an unknown solution, HCl, using a pH indicator, phenolphthalein. The solution will turn a pink salmon color when the solution's pH gets up to about a pH of 9.3, and it will drop down near to 7. Phenolphthalein is a weak acid. The weak acid itself is colorless, but the ion is a bright pink. The halfway mark for the pH is 9.3 because the pKa of the ion is 9.3. Here we are making titration. This is the burette, which is full of the titrant, NaOH, which is the base.
We'll add the base to the acid, HCl, to titrate it.
This is a strong base and a strong acid to make a strong titration.
To get an accurate measurement of the acid in the graduated cylinder, you have to get down to eye level and read.
And make sure you estimate 1 sig fig pass what the graduated cylinder reads. So here we would have a volume of 55.4 milliliters. The initial reading of the burette is 4.56 milliliters, which we need to figure out how much base leaves the burette and goes into the acid.
And we have a phenolphthalein indicator that turns the titration salmon once it hits a neutral pH of 7.
Look at the flick of that wrist. 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 I woke up feeling like I was on the moon. I woke up feeling like I need 100 goats.
The perfect shade. Oh, it's good now. Now we gotta keep a close eye on it.
We can't lose it now.
we gonna get it back? I know a guy about this situation. I'll give him a call.
What is it? What do you mean you lost the titration? Do you understand how much that's worth? It's worth $1 billion. Who took it? A guy in a yellow poncho? I think I've seen him working at Edible Arrangements. You're gonna have to check there. There can't be that many people working at Edible Arrangements wearing a yellow poncho.
On my mind, I got trouble on my mind. Trouble on my mind. So much trouble on my mind. Trouble on my mind. I got trouble on my mind. Trouble on my mind. So much trouble on my mind. On my mind.
Pharrell said get him, so I got him. Tripped and worse to Palin, then
Hey, is there a guy in a yellow poncho working back there?
There is, actually.
Alright, now we gotta spread out and search for him.
Alright, yeah, go this way.
Try to get it back to the first.
What's the Scooby-Doo? We're coming after you. You're gonna solve that mystery. I see you, Scooby-Doo. We're traveling after you. What's the Scooby-Doo? What's the Scooby-Doo? We're gonna follow you. You're gonna solve that mystery. We see you, Scooby-Doo. We're coming after you. What's the Scooby-Doo? Don't look back. You may find another clue.
I cannot find him anywhere.
Can't find him either, man. I don't know where he is. Did you hear that?
Yeah, I think I hear that too.
I think he's in the bathroom. You gotta check the bathroom.
oh, hogwash.
Who are you and where is our titration?
I'm acid brain. All right, get off me, I'll tell you. Only if you answer my chemistry questions. All right, question number 1. What's the pH of a 0.50 molar HCl solution?
Alright, let's think about this.
All right, HCl is a strong acid.
That means it dissociates 100%.
Therefore, the concentration of HCl is the concentration of H+.
And all I know is the pH is the negative log of the H+ concentration, so...
Oh, and 3 sig figs, 3 decimal places in the pH.
Good call, Sean.
0.301.
Oh, you guys must have a great chemistry teacher. All right, one more question. Identify the type of acid BF3 is. Lewis, Bronsted-Lowry, or Arrhenius?
Well, I know it can't be an Arrhenius acid because it does not form an H+ ion.
It's not Bronsted-Lowry because it's not a proton donor.
So it must be a Lewis then, because it's an electron pair acceptor.
Oh! All right, it's with the hydroxynator, but don't look in Warren by the pond. He's not fishing or anything.
All right, let's go.
I've been cheated by you since I drove away. So I made up my mind it must come to an end. Look at me now, will I ever?
Wait, here's someone. Excuse me, sir?
What's that?
Have you seen someone fishing?
Yeah.
Yeah, down this way.
All right. Thank you, sir.
Yes.
Hey, what are you fishing for?
Hey! Like I said, we gonna get right to the chemistry question! Ah!
Why is it always chemistry questions?
Hey! I'm asking the questions here, boy! What is the OH minus concentration of a pH solution?
All right. Well, POH is 14 minus the pH, so 14 minus 8 is 6.
And then you would take 10 raised to the -6 to find the concentration.
That'd give you 1.0 times 10 to the -6 molarity.
Ah! Lucky guess! But now, here's the second question. What makes up a strong base?
Calm down, man.
A strong base is a column 1A metal plus a hydroxide.
Like potassium hydroxide.
Well, that's correct. It seems there can only be one winner today, and it ain't me! Hey! Where's the titration? Hey! It's in the Linton office!
So it seemed like y'all been reading your Zumdal. You finally came to the right place. Do you really want that titration?
Where's the titration? Come on!
So it seems you're very angry, but that titration is very valuable to me. If you'd like it back, you'd have to answer some buffer questions. What makes up a buffer?
Isn't it a strong acid in its salt?
No, it's a weak base, weak acid in its salt.
Yeah, like sodium acetate or acetic acid.
Good answer. But the next question here is, what does a buffer do?
Well, I know buffers resist pH change when an acid or base is added to it.
Like blood in our body.
Well, it seems you know more than I thought. But the most important question of all, what is the Henderson-Hasselbalch equation?
I don't know. Do you guys know it? No. Wait! pH equals pKa plus a log of the concentration of the base over the concentration of the acid.
How could this be? But however, there is one thing you forgot. A good supply of body bags.
David! David, don't die.
Neutralizer, where's the titration?
Where'd you put it? It's in Mr. Shepard's